why do people act on scarcity? So people act on scarcity. Why do we act on scarcity? What is the problem here?
Well, because our resources are scarce.
Are finite. So scarcity means that resources are finite, but people always want them not to be such. So in this frame, we know that whenever people can choose, they will always choose that the more is better. So let me write it here. More is better. Why am I talking about this? Because not only does microeconomy talk about what do consumers want and how much they can afford, but the point is, how do consumers make choices together with what they want and how much they can afford? This is what needs mathematical and graphical tools to be tackled, to be treated. So we have that consumer choice. I hope you can read my handwriting. If not, I will. Okay. Is it a yes?
Yeah, it's yes. It's
okay,
fine.
Thank you. So our preferences plus budget constraint. What is a constraint?
Constraint, like ограничение.
Constraint is a limitation. How? Yes, constraint is a limitation. Very good. Very good. Okay, so can you tell me what a bundle is? This is one of the keywords that we are going to look at. Bundle.
Oh.
What is a bundle?
A bundle. I only know that it's somehow connected with products. But
yes. A bundle remember. That we can write like x1, x2 is an amount of good 1 and good 2. So is an amount of good 1 and good 2. How many objects, how many items can we put on a graph with this amount, with these bundles? How many goods can we describe?
Just 2. X1, X2.
Yes, well, this is what normal people would say. You know, we have 2 variables and we can describe the quantity of only 2 goods. But the answer is no, because economists, actually microeconomists, are the first one knowing that the resources are finite. So they tell, hey, what if I put like x1 is, I don't know, say cheese, and x2 is all the rest. All the rest. And this key I can put on a graph all what I want in what is called the 2 goods scenario. 2 goods 2 scenario. We are going to use this 2 goods scenario for everything, for goods, for preferences, for utility, for budget constraint, for income, for time constraint, when you can save money now to get something better in your pension retirement scheme, or the vice versa. Take a loan now to pay less interest later. So we are starting today and with this, and we will need it everywhere. So when we talk about bundles, we talk about preferences. When we talk about preferences, we think that they are complete. So for each type of bundle, you are always able to say whether one bundle is more or less than another one. They are transitive, which means that if I am going very short on this theory, very short, is if A is better, there is this this symbol for better, which is this one, like this. It is like an arrow. If A is better or equal than B, and B is better or equal than C, then A is better or equal than C, something like that.
So it's like math.
Exactly. What is the shape of the indifference curves? So indifference curves, and now I'm going to tell what it is. Curves are down sloping. How good are you at math? I'm great. I'm great. Good.
I hope I'm also good with math.
Okay. So can you draw what, in your opinion, is a downward sloping curve, please?
No, so curve is something like, not like a line, but it's
even a line in analysis. Even a line is a curve. Can you please draw it? You don't need to win any art.
Different curves.
Just draw something downward sloping.
No, for example.
Yes, great. Okay, this is a good example. So what you drew is convex to origin. What does it mean? Consumers.
Convex. Can you repeat again?
Convex. Yes, convex to origin. Convex to origin. Okay, roughly speaking, mathematically, this is a convex curve. Convex. In economy, this is convex. But it is convex to origin, okay? Convex to origin. Okay.
But what is convex? What does it mean?
I actually don't know whether it is vipukla or vigvognuta. I don't know. I always use concave and convex.
Okay.
So mathematically speaking, this is concave. But economists don't like convex or concavity, so they just use convex to origin. And this has a meaning. Consumers prefer variety. What does that mean? This position here is better than this one.
Okay.
So prefer variety to extrema. And by the way, the fact that they are inward, that they are downward sloping, means there is a trade-off. There is a trade-off between goods. So now, okay, there is a trade-off between goods. Now, let's talk about the indifference curve. What is this? This one, the thing that I drew here, is called indifference curve. So this one is the indifference curve.
Mm-hmm.
What is this? This is all the combination. Let me put it here like this. So this is all the combination of two goods that make you as happy. Economically speaking, we don't use the word happy, we use satisfaction, okay? Satisfaction. Or even better, you may hear utility.
Oh, so it means the same, satisfaction and utility.
Exactly.
Okay.
So along this curve, like this, along this curve here, you are as happy, Nina. So let's say that this is say in black, this is t, so x1, x2, okay, let's make it real. So x1 is t, x2 is coffee. No, I don't like it. Let's say tea and I don't know, biscuits. We will see that this is not even the best example ever. But anyway, usually let's follow a little bit of the scheme, and you may want to find the same thing in other textbooks. So x1 is food and x2 is clothing. So you have a budget constraint. You can't spend all the money in the world. Even if when I teach female psychology, I encourage doing differently. Now I'm teaching microeconomics. I haven't yet put all of this together. So you can't spend all the money in the world, right? So you have a budget constraint and you can spend it having a lot of food but little clothing, you see?
Mm-hmm.
Or vice versa. A lot of clothing but little food. And this combination make you as happy. But anyway, what do you see when reading this indifference curve? Whenever you trade some clothes, you get some food, of course. You can buy a skirt less, but more, I don't know, butterbrodi. Or you can have a dinner at a restaurant and go out with, I don't know, a garbage packet around yourself. Of course, actually, don't laugh. There is a whole trend in clothing where brands are making clothes out of garbage packets. Anyway, the best position ever is here, where you more or less equally share your budget between good 1 and good 2. Now, whenever you have several indifference curves on a graph, let me go down here, like this. Indifference curve never cross. So say that we have one indifference curve, the second indifference curve, like this, and let me label them. So this is IC1, this is IC2, and again, let this be food and let this be clothes. Please notice that what I am putting down on the graphs are quantities, okay? They are not prices yet, just quantities.
Yeah. Okay, quantity.
So they do not cross, first thing. Second, when we go outward, we gain satisfaction. Why is that? Well, look, here you have some clothes and some food, but here you have more clothes and more food. So since the more the better, satisfaction increases. So higher satisfaction. Very good. Now,
and IC, it stands for a
indifference curve.
right?
Yes. Now let's make it simpler. And let's talk about slope. So the simpler case is when we draw something like this. Oh, by the way, let me, before getting there, let me talk a little bit about the shape of this part here. So look, when we are here, when we are in this region here, we have a lot of food, and little clothing. In this region, we value little more food. Here, extra food means little. Because, look at this, to get one extra unit of clothing, you are ready to give away 4 units of food.
So extra food means
little.
Clothing?
Means little, no, just means little satisfaction.
Oh.
Means little satisfaction.
Okay. Yes, because we have too much food but not enough clothes.
Exactly. So you don't value food as much. Now let's have a look at the other part of the curve, which is gonna be, let's put it in green, like this, which is this part here. Here, the topic is exactly the same, but for clothing, because look, we are here, and we are ready to give away 4 units of clothing to get just 1 unit of food. So let me put it down. Here we value food more and trade it for a lot of
the less
clothes.
we have of something, the more
we want it.
Right?
The more we want it. Yes, the more we want it. So all this is the law of diminishing satisfaction. Law of diminishing satisfaction. In Russian, there is that poslovica, that phrase, which is "Даже икра ложкой надоедает." Okay, this is plain and simple microeconomics. Okay, now let's get here. We make it simple, so we put again food and clothing, and this time we use this type of indifference curve. Like this.
Or it's the demand one?
No. We are not yet talking about demand and supply, and today and the next one we won't ever, because I need the basics first. Of course, if you realize that you already know some topics, don't hesitate telling me, hey Philo, please, let's skip this one, I am okay. I will actually provide you with tests as well, and a little bit of homework. That's up between you and I to be discussed, but anyway. So what do you see? What can you comment talking about this curve? What do you see?
So no, it is very similar to our other indifferent curve, but it's like a line.
Okay, what does that mean? What does that mean?
It's the same logic. For example, like on top of it, like a lot of clothes but a little food, and bottom part a lot of food but not much clothing. Or maybe it's something else.
The quantity, I mean, considering the quantity, yes, you're right. But if we talk about the relative value of these goods, what can you see, since it is a curve, it is a line? So in, So in this case, I would like you to put down a comment, at least wordly.
Like it changes a lot, like rapidly.
In this case, food always cost the same amount of clothes.
How did you understand this?
Because it's a line. And because I am a professor of microeconomics. But anyway, here we talk about slope. In what is called, and now I'm getting technical, marginal rate of substitution. Ever heard of? Marginal rate of substitution. MRS.
I heard about it, but I don't know what is it.
Are you ready? Now you're getting more powerful and more developed.
Well, substitution is understandable, but what is marginal rate?
Marginal rate of substitution is, let me word it correctly. Well, graphically is the slope of the indifference curve. Slope of indifference curve. And now this is a line, which is
slope,
easy.
Just one more time. Slope is like indifference curve, but like a line.
No. Slope means it's the angle. It's the angle. So this is one slope, this is a steeper slope, and this is a flat slope.
Okay.
Okay. Moreover, let's get here. On this type of indifference curve, which actually is gonna be called Cobb-Douglas, and you may want to talk about this later, we see that here the indifference curve, look at here. Here the indifference curve is almost vertical, so very steep. Here the indifference curve is almost flat. In this case here, in the black case here, the slope is always the same. And let's read it. How many units of good 2 are you willing to trade for one more unit of good 1? Okay. Shall I write it somewhere? Let me do that like this. Allora. So slope of the IC, and let's call it instant slope, and I will get in math a little bit. So is how many units of clothes are you willing to trade for one more unit of food? Okay. So in formulas, we have the following. We have that the MRS is the negative ratio of MU1 divided by MU2. And put it there and we will explain it later on. Where MU is the marginal utility. Let me write it. Marginal utility. Intuitively actually, marginal utility means how much is one more unit of food make you happy with respect to one more unit of clothes. Good. So it's like marginal utility, marginal satisfaction, basically. Yes, exactly. Now, very quick mini exercise. I like doing mini exercise because keep attention up and keep you, interested and satisfied. So the marginal utility of our lessons increase because of doing mini exercises. So Masha loves tea and sugar, and she is willing to give up 2 spoons of sugar for 1 extra cup of tea. What is her marginal rate of substitution? But how do we decide if it's like 1 divided by 2 or 2 divided by 1? Well, in this case it is happy because I can tell you that t, we call t like x1, and sugar as x2.
So she's ready to give up 2 spoons of sugar.
2 spoons of sugar for 1 extra cup of tea. 2 spoons sugar for 1 cup of tea. The MRS is
so it's minus well, it's either 1 divided by 2 or 2 divided by 1. I don't know what is like.
Look at the formula. Look at the formula that is over there. I mean, at the left here at the left.
You mean the definition?
Yes.
How many units of
mu1 divided by mu2?
Wait. 1. So it's 1 divided by 2?
Exactly.
Once. Okay.
Exactly or not? Let me see. T is x1 and sugar is x2. 1 divided by 2. Very good. 1/2. What does it mean that we have a minus there? What if we had a plus?
I don't know.
Okay. Negative.
It's also strange because it's a minus, and how can we have like minus satisfaction? Or maybe some.
Let me explain. All right, negative, okay. Because the curve, the indifference curve, is downward sloping.
Okay.
If it was upward sloping, what would that mean?
So it's upward?
If it was upward sloping, it would mean that you would be happier giving away 2 spoons of sugar and 1 cup of tea. Not to trade, you see?
So I give away everything.
Exactly. You would be happier having less. Okay. But this contradicts the hypothesis that we were doing before. You'd be happier having less. Okay. Now, the next topic is utility functions. Ever heard of?
Not really.
Okay.
So it's like satisfaction functions?
We are talking about, yes, exactly. Exactly. Something like that, yes. So let me go here.
They're always talking about utility during our lessons, and I just realized that it's about satisfaction.
Exactly. Okay, I would like to crack a joke, but I won't. Utility function. Oh, by the way, it is nice meeting you. It is nice making your acquaintance. I'm very happy of having you as a pupil. We are going to win. So let's get on together.
Okay. I hope so. Thanks.
You hope, I know. Allora, what is a utility function? It is a function, and being a pro mathematician, you know that a function is a relation that assigns values to other values. which associates a number, a dimensionless number, to a bundle. So we take a bundle, x2, and we go to a number, which is going to be utility. The higher utility, the more preferred the bundle is.
Oh, so basically the more you want it, the more you prefer it.
Something like this. Yes,
something like this.
Exactly. There is 2 weeks of lectures that I usually do at my university on this, but we don't have time, so let's get on. There are several types of utility functions, and we are covering 3 or 4 most important, which have some properties that may be needed in the test. So one of the most common is Cobb-Douglas, by the name of 2 economists, Cobb-Douglas. Of the form u equals x1 to the a power times x2 to the b power. How does it look like? Well, mathematically, this is a kind of hyperbole. It is smooth, convex to origin, and looks like this. Of course, it may be like this, or it may be like that, depending on the different combinations of the 2 coefficients a and b, of the 2 exponents. Let me write it. So here, different a, b.
Also, AB
are
what
the
is AB? Like
are the
horizontal and
no are the coefficients of the variables. Look at this.
Okay.
And here I don't want to put anything in your mind that may distract, so the homework here is play with a and b and plot different curves.
So take different values of A and B and see how it changes.
How do they look like? Yes. Whenever you are going to do that, you will see that sometimes you get steep here and wide there, or you get something like this, or you get something like this, and this is what I would like you to talk me into. So if I put a greater A, the curve is steeper here, flatter there, and you know that the steeper it is, the more you want to give away that good to get the other one. Okay. This is the first type. Then we have perfect substitutes. Ever heard of?
Perfect substitutes. maybe it's like a substitute that's can be perfectly substituted, like equally substituted to something else.
Something like that. So whenever we have perfect substitutes, it means that your indifference curve first looks like a line, like this.
Mm-hmm.
You are equally satisfied here or there. So if you have a lot of A and some B, or a little bit less B and a little bit more A, you don't care. Because A and actually x1, x2 are perfect substitute.
Okay. So it doesn't really matter
how much
on the line we're at.
Exactly. In any case, it doesn't matter where you are because this is an indifference curve. So all the curve has the same level of utility.
Mm-hmm.
But you don't care about having a little bit more this or a little bit more that because you are always able to give the same amount of good 1 to get the same amount of good 2. So in mathematical jargon, we have ax1 plus bx2. So a linear combination of A and B.
Okay.
Example. Pepsi and Coke. Or in my own country, since I am Italian, actually my mother is English, but I won't ever call myself English, you have olive oil or Parmesan. You don't care whether you put a liter extra olive oil in your spaghetti alla carbonara or 2 kilograms more Parmesan. It is okay, it is the same. You can give me 1 liter and I give you 2 kilograms, or you can give me half a liter and I give you 1 kilogram. That's okay. Okay? Fine. Here, let me stress a little bit more. You are as happy if you consume 2 cans of Coke and 1 of Pepsi, or 2 and 1, or 3 and 0, or 0 and 3. All what matters is the final value of cans that you drink. Not which of what, but just the total. Good. This is the perfect substitutes. Now we are going to the last one. And as an exam note, and not because I am a bad professor, you are always going to be asked to interpret this shape of the indifference curve. So I draw it not for sake of fun, but because this is one of the most common exam questions. So the last one is perfect complements.
Oh, I remember complements is, for example, when you buy tea and then you're most likely to get sugar for it, something like that.
Exactly. You are most likely, but there is only one example that makes sense, which is left shoes and right shoes.
Okay.
So the utility is the minimum of the bundle x1, x2. Graphically, the utility curve is like this. utility raises like this, but only the minimum value of one of the two makes sense. So how do we read it? You are happy with 3 left shoes and 3 right shoes. So say that we are here. So let's take that this value here is 3. But you are as happy here, as much happy with 3 left and 15 right, because you don't care to have these extra 12 shoes. And you are as happy here of having 3 right and 15 left. You don't care. You only care of having the minimum of the two. Of course, here, go on.
I'm a bit confused. So X line is our, for example, right shoe, and Y line, like Y axis.
It doesn't matter. It doesn't matter. X1, X2 can be changed. Okay. Of course, if we go out and you have 7 pairs or 5 pairs of left and right shoes, you are happier, because the more the better. Or even here with 12. But you don't care whether you have 12 right and 24 left, or 12 right and 36 left. You see? You only care about the minimum, because they must be taken together. Okay. Now, are there any questions?
So about this, like, we care about the minimum, it means like we only care if we have at least like 1 left shoe and 1 right shoe?
Yes, right? Exactly. If you have 3 and 17, you don't care.
Okay.
Okay. Would you give me 1 minute break? I'll take some water, please.
Yeah, sure, okay.
Okay. Если на земле рай, это Краснодарский край, right?
Наверное, да.
Okay. Okay.
No, I was there once, but it was beautiful.
Well,
like the weather, it was so perfect. Compared to Moscow.
Well, I lived 5 years in Moscow and 6 years in Sochi, and I'm already living here 4 years, so it's a lot of time I am in Russia, and for the moment here it's the best. Compared to Sochi as well. Okay, so let's get on here. Now we're gonna talk about money, which means budget. No, I don't go. Let's put it in red. Yes, budget. So you can't choose whatever you wish. You must dream. Now I'm playing psychology. You must dream as though you had all the money in the world, but you have to make it cope with reality sooner or later. The more you dream, the more you're gonna get. This is again, spiritual lesson, but doesn't matter. In microeconomy, I don't teach okay, doesn't matter, and on a different basis. So whenever we have a budget, we must, okay, let's start with this. Whenever we have a budget, we must choose how to spend it between our goods in our bundles. So the so-called budget line has this equation: P1x1 plus P2x2 equals to M, where Pi is the price of good I, Xi is the quantity, and M is the budget.
Okay.
Now,
makes sense.
Can you try reading what is there, please?
You mean how it's how it's written, or
no? What
is
P1x1?
So it's basically price multiplied by the quantity. So it's how much we spend for some certain type of products.
Yes, exactly.
For example, three, I don't know, cups of 3 cups, and the same with P2 and X2.
Exactly.
2 pizzas, for example,
multiplied by $5 per pizza is your budget. Yes, very good. Now, can we draw this thing? Let me put it as a line here. Can you draw it, please? Or actually, I can draw it. So let's put it like this. Let's put it like this, and let's put it like this. So what is, no, leave it black. So what is this value here? And what do we put on our axis? On our axis, we always put x1 like the quantity of good 1, and this is x2 like the quantity of good 2. What are the intercepts here?
The intersects?
Yes, intercept.
Of x2 and x1?
Yes. How much are their values?
What is in intersect? So intersect of x1 and x2, or? Of
the budget line with the axis. So this one, how much is this value here? The answer
so it's 0x1 and something of x2.
Exactly. This is the situation where you spend all on
spend all on x2.
On x2. So how much are you going to buy if you spend all your money on x2? How much are you going to buy?
divided by x2.
No, m divided by p2.
It's like how?
M divided by p2. Right. And the same here, this is m divided by p1, correct? Now, let's talk about the slope. The slope is, mathematically speaking, minus p1 divided by p2. Isn't it?
Mm-hmm. So our angle is like price of one product divided by price of the second product.
Exactly. Exactly.
Okay.
This is the market trade-off, because we are talking about prices.
Mm-hmm.
Market trade-off. And now, what is this area here? Actually, let me make it different color. Let me make it in blue. Let me make this in black. What lies
maybe it's how many
between
products are available in general?
Not in general, but all the blue area shows you the bundles, the quantities of x1, x2 that you are able to afford.
Okay.
Blue is affordable. The red area over here.
Oh, so it's everything that we can't afford?
Exactly. Extra budget, which means too expensive.
Mm-hmm.
Now, let me put 3 points on this graph, A, B, and C. Are you happy at point A?
Probably not happy enough.
Not really. Are you happy at point B?
No.
Why
because
not?
we spend too much money.
No, you can't spend it.
I think.
You can't spend it. There is no loan here. So are you happy at B? Well, you would be happy, but you can't afford it. So the only real choice is point C, right? Very good. Now, we are going to talk now about the optimal choice. What is the optimal choice? Well, we are going to put together all what we have seen so far. So, optimal choice. The optimal choice is the maximization of utility subject to the budget constraint.
So basically, it's like maximum satisfaction we can get from our money.
Not from our money, but for our money. So
okay.
Your budget allows you to choose a lot of possible combinations, but you are going to pick the one under standard preferences that has the maximum utility. How does it look like? Graphically, you look at the point where the indifference curve is tangent to the budget constraint or the budget line. Graphically, we draw our indifference curves that we are going to have a look at this, and let's say that our budget line is like this. No, let me draw it like a line, please, like this.
1 second.
Yes, please.
Sei già da tanto tempo che qui lavori.
Sì, circa un'oretta. I need a second as well.
No, hai detto massimo alle 9, io sono qui.
Giù te che finì, non te che niente da fare altro, allora vestite, mettete il pigiama, te vieni su e te si alleni un poco a scacchi e dopo un poco di matematica. Vai.
Ora.
Mettiti il pigiama, va giù, sughite, mettiti il pigiama, calzetti e te torna su.
Sono già asciugato.
Ok, allora va giù, mettiti il pigiama, calzetti e te vieni su.
Metto il pigiama e calzetto vengo su.
Esatto. So, the optimal choice is this point here, is this point here. Why? Because of the whole indifference curve, you can't afford this combination. You can't afford this combination. So the only...
So the yellow line is our budget line.
Yes, exactly.
Okay.
The budget line, the yellow line is the budget line, and the black curves are the indifference curves. So my eldest is coming over, so I will give him something to play with just to keep him busy. I don't even know how much time it is, but it doesn't matter. So the tangency point where the indifference curve, like I see, meet the budget line gives you the optimal bundle.
Okay.
At that point,
like the best products you can get.
The best choice of product you can get. The best choices of product that you can get, that you can afford, not only that you can get and you can afford. Okay. Now, this, okay, at this point, the MRS, the marginal rate of substitution, is given by the ratio of the two prices. What does it mean? That at optimum, the consumer's choice, is equal to the market trade-off.
What is a trade-off?
Exchange.
Exchange.
Mm-hmm. Okay. Now, let me see. We are okay. We still have like 10-15 minutes, aren't we? So, like this. Example 1. You are given a utility of the Cobb-Douglas type x1 times x2. So A equals B equals 1. And the following prices. Price of the first good is $2. The price of the second good is $4. Your income is M equal $80. What is an analysis of this situation? What is the optimal choice? What is the best money you can spend on one and the best money you can spend with the other? What is the optimal bundle, and so on?
So is it that P1 divided by P2?
No, I didn't ask actually the marginal rate of substitution, but anyway. So look.
Okay, so by that formula, so our budget is 10, so we can
Is
get
80,
as
80,
many products
80.
as we can, just not exceed the
80, sorry, 80.
80, okay.
So let me quickly walk you through this one. So this type of utility curve tells you that the best share is for x1 equals x2 because A equals B. Hence, you are going to...
So A equals B, it means our perfect products are perfectly substituted?
No.
Or
let me put it in blue, and we talk about this one, that here these are A and B here. So there are two units there. So it is x to the first power times y to the x power. So we have, you will spend half of your money, so $40 on x1 and $40 on x2.
Okay.
How much of x1 and x2 are you going to get?
So x1 40 divided by 220, and x2 40 divided by 4, 10.
Yes. So what is the optimal bundle?
20 and 10.
2010. Very good. Very good. What is the marginal rate of substitution?
Like 1/2.
1/2.
Minus 1/2.
The marginal rate of substitution is just the ratio between the two. The slope is negative. What does that mean?
That the second product is like twice, like the first product is
You will
like costs 1/2 the second one.
You want to give away 2 units of good 1 to have the same unit of good 2.
So this marginal rate
Of
substitution is
substitution.
about like always giving away
is about the
things,
trade-off.
right?
Yes, is about the trade-off. Ok.
Eccomi qua.
C'ho un telefono, cominciamo a giocare. Abbiamo ancora 5 minuti. C'ho un telefono, cominciamo a giocare. Good. Now, I guess the last part is a little bit of quiz about what we learned today. So, indifference curves never cross because transitivity, monotonicity, convexity, A and B.
Okay. Monotonicity is
like, always growing.
Wait. Sorry, monotonicity is like
when something is always growing. Look, I am drawing it. Okay. So look, this is monotone. This is monotone. This is not monotone.
Okay.
So indifference curves never cross because of transitivity, monotonicity, convexity,
what is transitivity?
If A is better than B and B is better than C, then A is...
Okay. Like preferences.
Yes.
Okay. All right.
Okay. What is the correct answer?
One second. Not like, I think convexity?
No, both transitivity and monotonicity. The fact that they are convex means that you are only happy when giving away one for the other. You won't be happy of giving away both. If you give away, let me write it here. So convex IC means you are happy if you trade not if give away both. Because look, if the indifference curve was like this, you would be happy of having 3 apples, 3, I don't know, golden rings, as well as 8 apples, 8 golden rings, which of course doesn't work. Okay, good.
Okay.
Now, next question. What does the marginal rate of substitution, so MRS, measure? Let me, this is a multiple choice question. The point is that I didn't copy and paste, but it doesn't matter.
Measures the units that a consumer is ready to give away. Wait.
Go on.
Like, how many units is consumer is ready to give away for another?
Yes.
Units of another products.
In other words, the willingness to trade one good for the other. Trade means exchange, okay? Okay, good. Now, last one. If P1 increases, the budget line you may want to draw it first.
If P1 increases,
what happens to the budget line?
I think it just goes right.
Would you like to draw it, please?
So, budget line. So this is our initial budget line.
Yes. You want to intercept the axis, otherwise you can't tell what P and P1 and P2 are.
Okay. If P increases, so the price of a product is increased.
If P1 increases, what happens?
Like this way?
No.
Like, no?
This, let me make it in blue. Blue. So the budget line shifts out.
Also,
if you increase the budget.
Just have more
exactly,
budget.
Exactly, increase. If your money increases. Dime, what does it mean?
Cosa vuol dire pretty please?
Sono parte di una frase. So, what happens if P1 increases? Just look at this. This is M divided by P2. And this, and this is M divided by P1. So if P1 increases, what happens?
If P1 increases, then we have less X1, I guess.
Exactly.
The budget line. Oh, so it's probably goes like either up or down?
No, because the price of good 2 remains the same.
No, io non volevo. Non mi ascolta.
They just stay the same budget line?
No.
No?
You told me correctly. You told me if our price increases, we get less of X1. So here we have M divided by P1 first greater than P1. So the line is going to be this one, which means it becomes steeper.
Okay.
Got it?
But I don't understand because the budget line is like how much money we have. So why our
No,
budget
no.
changes
The
when the
budget,
price changes?
no. The budget line is not the money we have. M is the money we have. The budget line is P1x1 plus P2x2 equals M. This is the budget line.
Mhm. Yeah, then I understand. Okay.
Good. Then this is how much I